Hi guys, in this video we're going to go through the measures of central tendency. Uh, these measures help us understand where a particular data set is kind of gravitating towards. There's three common ways that we find central tendency. The first is the mean, also known as the arithmetic average. There are easy ways to calculate this, I'm sure you're all familiar with. You simply sum all your data points and divide by the number of data points. Okay? And you can do that for a population, which we abbreviate as mu, or you can do that for a sample, which we abbreviate as x bar. If you do a population or a sample, the process is the same. Okay? If I were going to find the arithmetic average mean height in our class, I would ask everybody their height, I would add it all up, and then I would divide by the number of people in the class. The problem with the mean is that it is affected by outliers. If, for example, one person in the class happens to be 6'8", that's going to create an upward kind of bias. Okay? That's an outlier. Most people in the class would not be close to that height, but one person having that height will make the mean height look higher, which means the mean would not accurately represent what is typical in the class. That doesn't mean we don't use the mean. We just have to be aware that it is affected by outliers. Another example would be with housing. If you have a neighborhood where the typical home is, $400,000 or $500,000, and then somebody builds one home in the neighborhood that is $1.5 million, well, now you have an outlier, and that's going to make the mean price for homes in that area go up, and the mean may no longer represent what is typical. To deal with these outliers, we sometimes use a trimmed mean, which means that we get rid of the outliers. We can use the mean for any set of data. It's very versatile, but it may only be appropriate for data that does not have outliers. The median is another measure of central tendency. It's sometimes called the midpoint. And this is where we put our data set in numerical order and then find the middle value. So if I go back to height, I would take the shortest person and then go all the way in order to the tallest person. Just imagine a spreadsheet with the shortest person all the way to the tallest person. And then I would find the middle value. Because we're not using a mean, we do not experience the same outlier issue. In other words, if that person that's 6'8" is in the data set, we're going to get a median that is not that much different than if that person was not in the data. So it's not affected by outliers. Same thing with real estate values, housing. You build that $1.5 million home and you don't get the same outlier effect. So you'll find when looking at data that does have outliers, like housing, the median is usually preferred. If we have two data points in the middle, then we just average those together. That's saying that we take the mean of those two middle values. And then the third form of central tendency is the mode. This is by far the least used measure of central tendency. And the reason is because it just doesn't work well with a lot of data sets. The mode is the most frequent data point occurring. Okay? So imagine that we tried to use the mode with height. Well, how many people in the class are going to be an exact height, like 5'10", 5'9", 5'8"? Right? It wouldn't usually be very accurate. And if we did height to the decimal place, then we might even find that there is no mode. There is no most frequently occurring data point. It is not affected by outliers, okay? But again, it may not exist. Or data may be multimodal. You could have a data set that has the most frequently occurring data point multiple times. In other words, you could have in our class, let's say 3 people that are 5'8" and 3 people that are 5'6". So you would have a bimodal data set there where you have 2 modes. It's particularly appropriate for qualitative, categorical data, not so appropriate for numerical, quantitative data. And the reason is because with categorical data, we can define the categories in a way to where the mode has meaning. For example, if I'm going to do a survey and I want to have, let's say, 5 stars, with 1 star being the lowest ranked and 5 stars being the highest ranked, well, I've created categories, right? And what might be meaningful to me is the number of people that have given a restaurant, let's say, 5 stars, or the number of people that have given a restaurant 4 stars. I want to go to a restaurant that has the most frequently occurring 5 stars, not a restaurant that has the most frequently occurring 1 star. And when you're dealing with survey data in particular, this is helpful because the median and the mean may have no real value. To say that one restaurant, or let's say that one survey respondent for a restaurant gives it 5 stars and another survey respondent gives it 1 star, it wouldn't really be meaningful to say, well, that it suggests that the restaurant is a 2.5, right? Or a 3. So we don't average or find the median for survey data. And I'll tell you who else doesn't do this are the owners of businesses. If you've worked in a customer service business where you are being surveyed, they prefer to look at the frequency, right, of stars or ratings rather than the mean or the median. I want an employee that is getting a lot of 5 stars, not an employee that gets, the same amount of 5 stars and 1 stars, giving them an average of, 3. So the mode is useful in very specific instances like consumer surveys. But you're going to find that the mean and the median are the most common. Another type of measurement that's often used for central tendency is the geometric mean. This is a little bit different than the arithmetic mean because we use this when compounding matters. For example, let's say we have an investment that is worth $100,000 and it goes to $150,000 at the end of 1 year and goes to 180 at the end of 2. We want to know how much that investment is growing on average over those 2 years. So we do this through the following formula. We find the growth rates first, and you can easily see this. If we go from 100,000 to 150, well, that's a 50% increase. And then if we go from 150 to 180, well, that's a 20% increase. So once we have the percentage changes, we can then plug them into this formula. We take 1 plus 0.5 for the 50% increase times 1 plus 0.2 for the 20% increase, and we only have 2 increases, so we would stop there. And then we take that to the 1 over the number of intervals. And here we have 2 intervals, right? Because we went from 100 to 150, that's 1 interval, and we went from 150 to 180, that's 2 intervals. And then we take that 1 over 2 exponent and we subtract 1. So for example, in this case, we would have 1.5 times 1.2 to the 1/2, and then minus 1. And if you do that, you will get, here's the actual formula down here, you will get 34.16%, which means that on average, this investment increased 34% each year. If you take 100,000 and add 34% to it, and then take whatever number you get and add 34% to that, you will get to 180. Okay, so that's a 34% geometric mean. Now, this lies in contrast to the arithmetic mean, because if you just take the 50% and add it to the 20% and divide by 2, you get 35%. But that's misleading. Because of compounding, if you take 100,000 and add 35% to it for 2 years, you're going to get more than 180. So the geometric mean represents the actual compounding rate of increase better than the arithmetic average. Okay, so anytime you're compounding, which would be with investments or maybe with an economic growth analysis like gross domestic product or national income, you would want to use the geometric mean. Let's keep going. The weighted mean is another measurement that's often used when our data has different weights. And this is one that's often used in investments as well. So here's the formula. What we do first is we find our weights. So let's say we have these investments: stocks, bonds, cash, commodities, and real estate. All right, the 5 basic categories of investments. And let's say our portfolio is allocated with the following weights. Let's say we have 50%, half of our investments in stock, 20% in bonds, 5% in cash and commodities, and 20% in real estate. Now, anytime you're using a weighted mean, your weights should sum to 100. And if you look at these, they do. They sum to 100. So we've accounted for all the portfolio. Now, what we do once we have our weights, W, we then use this formula. Okay? So we're getting on stocks a 12% return. So we take the 12%, which is our X, times the weight, which is 0.5, and you're going to get W times X, weight times expected return of 6%. And then you do the same thing for bonds, right? You take the weight, which is 20%, times our expected return, which is 5%, and you get 1%. And you keep going. And then once you've multiplied each weight times its expected return and added them up, you have the weighted mean. So the weighted mean here is 8%, which means if you are a person that has your portfolio allocated in this manner and you have an expected return on those investments of this amount, then we can expect your portfolio to grow by 8%. That would be your average return on your portfolio. Now, if you used, instead of the weighted mean, you use the arithmetic mean, you would encounter a problem. Because if you take the 12%, the 5%, the negative 3%, the 20%, and the 5%, add them up and divide by the 5 investments, you get 7.8%. And that's not accurate, because what an arithmetic mean does is it gives every single investment the same weight. It's as though your portfolio allocation is 20% for every single investment. But that's not the case. You have half your portfolio in stocks. So stocks need to be given more weight. Whatever return you get on stocks needs to be given more weight. And the same is true for something like commodities, where it's a small percentage of your portfolio. We don't want to give that 20% weight. We want to give it 5% weight. So the weighted mean does this and is appropriate anytime your data has different weights. Another example of this, by the way, is when we look at your grade point average. You may not realize this, but it is a weighted mean. So for example, here we have a student with English, Econ, Stats, and Spanish, and we have to find the relative weights based on the units, right? So it looks like Econ and English are 3 units, so they have a 20% weight in this 15-unit portfolio, and then Statistics is 4 units, so it has a 26% weight, and then Spanish is 5 units, so it is a 33% weight. You do the same process. You take the weight times the grade points, and you get the grade point average by summing those up. If you did the arithmetic mean, you would make this student look more proficient than they really are, 2.5 versus 2.267. All right, let me know if you have questions.